Our second method for simplifying complex fractions requires us to look at the individual fractions, the individual rational expressions that make up the larger complex fraction, and think about their common denominators simultaneously. So in the previous example with the previous method, we only looked at the numerator and the denominator separately. What did I need to create common denominators in the numerator, and what did I need to create common denominators in the denominator of the complex fraction? Method number 2 says look at everyone together. And when you look at everyone together for this particular example, you should see a common denominator of x minus 3 and x plus 5. So this denominator right here is covered by the x plus 5, that's the x minus 3, and that's also covered by the x plus 5. And what we're going to do is we're going to multiply the numerator and the denominator of this entire expression by the factor x minus 3 over times x plus 5 over x minus 3 times x plus 5. Now, remembering our basic rules from pre-algebra, we know that that fraction has a value of 1. So we're not actually multiplying this fraction, this larger complex fraction, by anything more than 1. What this is going to allow us to do, however, is to simplify the expression and write it so there are less fractions. Essentially, it's going to eliminate the complex part of it having fractions. There will still be a rational expression at the end, and we will still need to do factoring and canceling, and we will still need to look for those common factors. But multiplying the numerator and the denominator by that common denominator is going to free up all of those extra fractions that appear in the expression. So every term, I shouldn't say every term, every fraction is going to get multiplied by that factor x minus 3 times x plus 5. Our denominator, each of the fractions in the denominator, are also going to get multiplied by that common denominator. And again, this only works because it's the common denominator of everything. It's not just the common denominator of the numerator or the denominator. It's the common denominator of all of the different fractions. Doing some simplifying, this x plus 5 will knock out that denominator. This x minus 3 will knock out that denominator. And this x plus 5 will knock out that denominator. And we get a simplified version of this rational expression of 3 and x minus 3 in the numerator and 2x plus 5 plus 1 x minus 3 in the denominator. Now this should look familiar because this was the same point we got to when we did the example using method number 1, the same example we did with method number 1. It creates the exact same solution. We didn't multiply by anything other than a factor of 1. We just wrote it using common denominators. And then we simplify from there. This denominator has a value of 2x plus 7. So we have a final, 3x plus 7. My apologies, 3x plus 7. So we have a final version that is 3 times x minus 3 over 3x plus 7. Nothing can be factored anymore from this denominator. And again, we remind that we cannot be negative 5 or 3 because of their rules in the common denominator. Simplifying using method 2 requires you to look at the common denominator of every fraction in the complex fraction and to simplify from there. It is not an exercise in treating the numerator and the denominator separately. Instead, we look at the complex fraction as a whole. And as we eliminate those common factors that appear in the numerator, in the denominators and in that common denominator, we create something that's much more simplified and again, only has the look of a rational expression as opposed to being a more complicated complex fraction.